Hi everyone. This is example 10 from chapter 12 in the student packet. It says, in its monthly report, the animal shelter states that it currently has 24 dogs and 18 cats available for adoption. 8 of the dogs are male and 6 of the cats are male. Suppose an animal from the shelter is randomly chosen. Find the following probabilities. So first, I'd like to get down all the information. So we have 24 dogs. And we know that 8 of them are male. So we have 8 male. That leaves 16 as female. We also have 18 cats. And we're told that 6 of those cats are male. So we know that 6 are male, leaving 12 to be female. So now let's answer our probabilities here. It says find the probability that a pet is male. So the other thing I need, which I forgot to do here, is I need a total. So I know there's 24 dogs and 18 cats. So that will give me a total of, let's see here, 42. So I have a total of 42 animals. So what is the probability that we have, or that we choose a male pet? So choosing a male means that we're going to choose a male dog or a male cat. And I said Kate. Hold on. There we go. So choosing a male dog, we have 8 male dogs out of all the pets. And we have 6 male cats out of all the pets, giving us a total of 14 out of 42. And if we put this in our calculator, we'll get 0.33 or 1/3 if you want to write it as a fraction. For part B, it says, what's the probability that you would choose a male given that you've already chose a cat? So there is a formula for this, but I'd rather you think about this logically, since we have a discrete count of dogs and cats and male and female pets. So the probability that we choose a male given that's a cat. So if we already know that we're choosing a cat, then our total is this 18 cats, because we know that we've already chosen a cat. Of those 18 cats, how many are male? Well, they told us 6. So again, this is 1/3 or 0.33. Now, I have part C here because I want to show you that the order on these given problems does make a difference, because part C says, what's the probability that you choose a cat given that you've chosen a male animal? So now we have a different total. Now our total is the total number of male animals. And let's see, I have 8 male dogs and 6 male cats, giving me a total of 8 male animals. Now, of those male animals, how many of them are cats? That would be 6. And 6 over 14 is the same as 0.43. Then it says, are the events of selecting a male and selecting a cat independent? So this is kind of our first discussion of independence, and we're going to use a formula. So if you think about what independence means that if one event occurs, that event does not affect the probability of the other event. So what we want to say is, let's choose one of these events. We have 2 of them, picking a male or picking a cat. I already have in part A the probability of picking a male, so I'm going to start there. I know the probability of picking a male is 0.33 or 1/3. Now I want to know if choosing a cat affects the probability of choosing a male animal. So I want to compare this to the probability of choosing a male given that I chose a cat. Notice that, hold on, I'm trying to find another color here. Notice that this and this are the same because I want to test whether or not the probability of choosing a cat affected the probability of choosing a male animal. So I leave those the same. And I have that calculation as well. That's in part B. And we can see that that also equaled 0.33 or 1/3. There we go. Now, since these values are the same, it means that choosing a cat did not affect the probability of choosing a male animal, and therefore these events are independent. So since the probability of choosing a male equals the probability of choosing a male given a cat, then the events are independent.